Here we have an electrical code problem that is asking how far we can run a 10 gauge wire if the voltage is 240 volts, the current is 4 amps, and we will accept 2.5% voltage drop. So this is a voltage drop electrical code problem. We're going to use the Canadian Electrical Code 2024 release where we use table D3 for our voltage drop calculations. So our solution. If you haven't seen already my videos about coming up with an equation to do voltage drop, then now's the time to take a look at that. All voltage drop problems can be solved by the following equation, which is sort of mentioned at the top of table D3 in the Canadian Electrical Code. But here I'm presenting it with units and some variables so that it's easier to kind of substitute in and know what we're doing. It's a bit of a universal way of solving these problems. So I will write that equation for you in the same way that I do always for you for consistency. And once you do a few of these problems, you'll see that it's all about substituting and rearranging the equation. So the voltage drop calculation has 1,000 meters per kilometer, which is just a unit conversion. And then it has voltage drop in volts. So for that, I would go the voltage times 2.5% to get that. It has, excuse me, a K factor. It has K from table D3 is a factor that came out in the 2024 edition of the Canadian Electrical Code, and it is it's a K value plus times a factor that you multiply it by, which is called note 3. And then there's F is in note 2, actually. Note 2, and depends on the type, the application of the conductor, your current, current and length. In this case, we are going to solve for length. And when we're solving for length, it is in meters in this equation, and really it means that the length has to be less than or equal to what we can calculate here. So I'm going to solve for length. If you don't know how to solve for length, put a comment below and I will help you with the rearranging of equations and such, because everybody is at a different point in being able to do so. I'm rearranging this equation, and I would have K factor 3 at the bottom, F from note 2 of table D3, and my current and my length on the bottom here. So length is going to have to be less than or equal to, and now I can just sub in these values. The voltage drop would be 240 volts times 2.5%. I'm going to erase that actually, and I'm going to present that as a decimal place times 0.025 is the decimal equivalent of 2.5%. The factor K, I would look at table D3, and I would see that for a 10 gauge wire, the table D3 says to use 4.03 ohms per kilometer. So I'm going to sub that in, 4.03 ohms per kilometer. And then the F value from note 2 is 2. In most cases it is 2, and you can look at my other video if you need to see the details about that F factor. And then the current in the question, it said it was 4 amps of current. Then we can plug all of that math really into our calculator, and we see that the length has to be less than or equal to 6,000 over 32.24. And this will be in meters times volts on the numerator there per kilometer on the denominator of my numerator over ohms per kilometer. It's important to keep all of our units because If these units are wrong, then that means I've probably done something wrong in rearranging this equation or substituting in values. So let's see if these come out correct. I have a kilometer up here and a kilometer down here that can cross out. I have a volt over an amp, which is the same as an ohm because V equals IR. Voltage equals current times resistance. Therefore, voltage over current is equal to resistance. So I can cross those out. And I'm left with just meters. So that's 6,000. Oops. I can divide those two numbers. Then that'll give me 186 meters. I'm happy that I see meters in there, and that makes sense. So therefore, 10 gauge wire at 240 volts and 4 amps, we can if we let the voltage drop to 2.5%, which is kind of high, we can run 186 meters of length of that cable. Hopefully, this has been a good example problem for you. If it is helpful, please click like, please subscribe for all of the other example problems, and comment what you liked about it and what you still need to know below. Thank you so much.